Hello everyone. This is the start of the quiz revisions, numbers 1 through 8, the most recent quiz, and I'm going to go through these relatively quickly. I'm not going to go through every single step of every single problem, but I should be able to provide you with enough guidance to be able to revise your own work. I'm going to go relatively quickly, so if you need to stop the video to pause it and grasp everything that's being said, you can do that at any time and watch any item as many times as you like. So I'm going to start with number 1. This one is 32 is what percent of 40? A number of people made errors on this one, and I think the most common error was setting up the proportion incorrectly. When you see, I'm going to change colors here. When you see that 32 is what percent of 40, when you see this term what percent on there, that is a clue that the percent is the unknown. So when you set this up as a proportion, you can set it up as x over 100, something out of 100. Every percent is a number out of 100, so when the percent is unknown, that's where the x goes. And the rest, 32 is, tells you that's the numerator. And of 40 tells you that's the denominator. So you can set that up to get your answer. 32 times 100 divided by 40. You can set that up like this. That would be 3,200. So then you end up with 3,200, 3,200 divided by 40. And what percent ends up being the answer? And it's 80%. Okay, 32 is what percent out of 40? Since those are both even numbers, you could simplify that problem to 16 is what percent of 20, and those are even numbers, so you could simplify that as well to 8 is what percent of 10. So if you divide each one of these numbers by 4, 32 divided by 4 is 8, and 40 divided by 4 is 10, then you have a much simpler problem as well. 8 is what percent of 10? And that's 8 out of 10, and that's 80%. So that's your answer. Number 2, 56 percent of 75 equals what number? This can be seen as a multiplication problem, and setting this up is important. I think the most common error here was multiplication errors, or that this was set up as a proportion incorrectly. So I'll show you how to set it up as a proportion, but also know that when you have of in between two numbers in a percent problem, that means it's going to be multiplication. So we have to take that percent and turn it into a decimal, 0.56, and multiply it by 75. To set this up as a proportion, 56 is the percent, so that's going to be the number that goes up over 100, equals x over 75. We know that 75 is a denominator because it comes after the word of. Excuse me. So 56 over 100 equals x over 75. You multiply these two numbers here, divide by that number, and you end up with 42. I noticed that there were a number of answers that were all over the map for this problem. One thing to do right off the bat is to try to understand what this problem is asking, and we know that 56% is a little more than half. 56% is a little more than half, so a little more than half of 75. And so I had some answers that were over 75, that were close to 75, but a little over half is not going to be very close to 75. So 42 would be within the ballpark. If you were to estimate what's a little bit more than half of 75 and you estimated 40, then that's a reasonable guess. But 70 is going to be way too close. That's going to be up in the 90s in terms of the percentile as opposed to 56%. Okay, so that's numbers 1 and 2. So I'm going to switch to another screen. Now we have solve for x, and this is a proportion in itself, just like the proportions that we use to solve percent problems. 14 over 18 equals 42 over x. Now immediately I see a number that can be simplified, and 14 over 18 is the same thing as 7 over 9, because both of those numbers are divisible by 2. So I can say 7 over 9 equals 42 over x. And already I have a much simpler problem. I can multiply these two numbers, 42 times 9, to get 378, and divide that by the remaining number here, which is 7. 378 divided by 7 is 54. And that ends up being the answer. 14 over 18 equals 42 over 54. Now another way to look at this is to know that 14 is actually a factor of 42. So if we know that 14 times 3 is 42, then we can multiply 18 times 3 to get 54, and that would be our answer also. So there are a couple different ways to find the answer to number 3. Let's move on to the next one, number 4. Number 4 is a series of order of operations where we have 4 2/3 minus 2 2/5 in parentheses on the left, and that's being added to a division problem. 3 1/2 divided by 1 1/4. So we might want to start by finding common denominators for the operation on the left. If we want to go in the parentheses, there's also another operation on the right that's division. It doesn't matter which one of those we start with because they're both separate operations isolated in parentheses. So if we start with the common denominators here, on the left we would have 4, instead of 2/3, we want to find 15ths because we have 3 and 5 here, and their least common multiple is 15. So let's look at that. So 3 times 5 is 15, 2 times 5 is 10, so that's going to be 4 and 10 15ths minus 2, and 5 times 3 is 15, and 2 times 3 is 6, so that's 2 and 6 15ths. Whoops, excuse me, that looks like a 16. There we go. 2 and 6 15ths. So right off the bat, we have something that we can actually work with on the left, and we can simplify that to 2, because 4 minus 2 is 2, 10 minus 6 is 4, 2 and 4 15ths on the left. So now we have to take care of the operation on the right. And here we have two mixed numbers, and if we want to be able to divide them, it may be easiest to put them into improper fractions. So let's try that. 3 times 2 is 6 plus 1 is 7. That's 7 halves. Divided by 1 times 4 is 4 plus 1 is 5. 5 fourths. Now, the rule for dividing fractions is that we can multiply the reciprocal. So that means we're going to take the second fraction and flip it upside down and multiply. So that turns that into 7 halves times 4 fifths. And already we have something we can simplify now. This can become a 1, and this can become a 2. So now we have 7, we multiply fractions straight across. So 7 times 2 is 14, and 1 times 5 is 5. Now if we hadn't simplified that, we could still do it just the same. It would be 7 times 4 is 28, and 2 times 5 is 10, so that would be 28 tenths, and we could continue to solve the problem. But this way, it's smaller numbers, so it makes things a little bit easier for us. So we have 14 fifths, 2 and 4 15ths, plus 14 fifths. Now, we can add mixed numbers, so I'm going to just turn this back into a mixed number. So this one stays the same, 2 and 4 15ths, plus 5. There are 2 5s in 14, plus 4 left over, so that's 2 and 4/5. But now we need to turn these into common denominators as well. So we have to turn that into 15. So if we have 2 and 4/15, now plus 2 and 12/15, that gives us 4 and 16/15. So we're not quite done yet because now we have an improper fraction embedded into a mixed number. So we simply need to turn that into 5 and 1/15, which is our answer. So I went through that whole problem because there were people who got this one wrong. There were errors kind of all over the different parts of that problem. So I wanted to make sure that we went through that bit by bit. Feel free to stop and review that at any point. Okay, I'm going to go on to number 5 now. This is a long order of operations problem. And we have 4 to the 3rd power plus 12 divided by 3 times 2 minus 12 divided by 2 times 4 plus 2 to the 3rd power finally divided by 2. So I'm not going to take too much time with this one other than to just show you right off the bat the first few sets of simplification. So we know that if we follow the order of operations, we start with parentheses, and there are no parentheses, and so we'll go next to e, which is exponents, and there are a couple sets of exponents. There's one right here, and there's an exponent here as well next to a division problem. There's also division and multiplication left to right. Here we have that again, multiplication and division left to right. So we have a few things that we can simplify here. 4 to the 3rd power is 64. That means 4 times 4 times 4, right? And 4 times 4 is 8. Excuse me, 4 times 4 is 16, and 16 times 4 is 64. And so that will be added to this next thing here. So here we have 12 divided by 3, and this is where some people made the mistake and saw this 3 and 2 and multiplied that first, but you don't do that. It's 12 divided by 3. We do it left to right. 12 divided by 3 is 4, and 4 times 2 is 8, so that's going to be an 8. Then we have the subtraction sign here. Do the same thing over here. 12 divided by 2 is 6, times 4 is 24. Then plus here we have 2 to the 3rd power, that's 2 times 2 times 2, which is 8 divided by 2, which is 4. And now we have a much simpler order of operations problem. So we end up with 72 over here, and we're going to subtract 24. That's 48. And we still have to add this 4 over here. And that gives us an answer of 52. Okay, so we ended up going over that one pretty much in its entirety, but we did it relatively quickly. Again, you can go back and watch that part again if you'd like to. Moving on to number 6. Okay, number 6 was a division problem. There were a fair number of errors on this one. It looks pretty simple. It is pretty simple, but there are still ways that sometimes mistakes are made. The first thing to notice here is that there are 2 decimals, and they are going to have to move, but we don't need to do that yet. Let's look at this first and try to understand what the problem is. In any division problem, you can look at the second number, the divisor, and ask yourself, how many of these fit into that? So if I were to estimate this, 0.6 is really close to 1/2. 29.7 is really close to 30. So how many halves fit into 30? Well, that would be about 60, right? So this is going to be a pretty big number. This is one of those division problems that actually ends with a higher number. Anytime you divide something by another number that's less than 1, you're going to get a larger number than you started with, because we're asking ourselves, how many of these fit into that? And it turns out it's quite a few, quite a lot, I should say. So let's set this up. 29.7 divided by 0.6. Now we can't have a divisor with a decimal, so we're going to move that over. We're going to move that over as well, and we're going to put that decimal point right up there because that's where it's going to stay. when we do division problems. It's one of the common mistakes that people do is they move those decimals and then they do the division and they solve the problem. Then they move the decimal again for some reason, and you're not supposed to do that. You leave the decimal right where it is. And when we divide, this becomes 297 divided by 6 instead of 29.7 divided by 0.6. It turns out the answer to both of those problems is the same number, and it's 49.5, right? 6, we can put 4 6s in 29. 4 times 6 is 24, right? And then we end up with a 5. Bring down that 7. 9 6s go into 57, so 9 times 6 is 54. Here's a really common error right here. That leaves us with a remainder 3, but we don't express answers in 7th grade with remainders anymore. We will keep going, and we're going to bring down that 0, because now we have the decimal point that's here, right? So we're going to bring down that 0. Now we're asking ourselves how many 6s fit into 30, and it's 5 right there. 5 times 6 is 30 with nothing left over. So we don't have that pesky remainder to deal with anymore. I did not give credit for most of the answers that read 49 remainder 3. The other way to write that would be to take that remainder and use that as a numerator and that 6 as a denominator, so it would also be known as 49 and 3/6. If you wrote your answer like that, I would have given you credit, because that's the same thing as 49 and 1/2, which is the same thing as 49.5. All right, that's number 6. I'm going to skip number 7. That was the ordering fractions problem. Everybody got that one right, so I don't find any real need to go over that one. Just about everybody got that one right, I believe. All right, number 8 and number 9, we're getting close to the end here. 3 divided by 5 plus 4 divided by 8. Oh, whoops, I'm sorry. There we go. Now we can see them. 3 divided by 5 plus 4 divided by 8. This one sent some people for a ride. Whenever you see division problems like that, you can rewrite them as fractions. 3/5. 3 divided by 5 and 3/5, that's the same thing. Plus 4 divided by 8 would be 4/8. I'm going to go right ahead and simplify that to 1/2, because I know that 4/8 can be simplified to 2/4, which can be simplified to 1/2. So now we're looking at 3/5 plus 1/2. And that's pretty easy to find common denominators for. 10. So that would be 6/10 plus 5/10. That gives us 11/10, which is 1 1/10. Okay, a number of people used decimals and found the answer to be 1.1. I gave you credit for both of those. Number 9, 7 4/9 minus 3 5/6. We had a fair number of errors on this one as well. A number of people got it right too. With 6 and 9, that gives us a convenient common denominator, of 18ths. And if you turn that into 18ths, you get 7 and 8/18 minus 3 and 15/18. So if you want to then borrow from this 7 and turn that into, take 1 away from there in the form of 18/18, that gives us 6. There's the 1 that we took away, with the 18/18 plus 8, which gives us 26/18. Now we can subtract those 3 and 15/18. And we're left with 3 and 11/18. And that's the answer that we got. Okay, one more problem. The last one, it's an order of operations situation here. Again, it was set up just like this. So there were a number of errors here, and this is the one where most people fell for the trap of multiplying before dividing, when in this case you had to divide before multiplying. So I'm just going to simplify this again, just to show us that, oh, I think I have a number wrong here. It's 24 divided by 4. This is a 4 right there. 24 divided by 4 plus 90 divided by 5 times 3 plus 2 to the third power divided by 2. So the first thing we notice that there are parentheses, and within the parentheses there's an exponent. 2 to the third power is 8. So here you have 3 plus 8 divided by 2. And you have to do that division first because division comes before addition. So 8 divided by 2 is 4, 3 plus 4 is 7. And then this is where a lot of people made mistakes. They set this up as 90 divided by 5 times 7 and did the 5 times 7 first. You don't want to do that. We have division and multiplication left to right. So 90 divided by 5 is 18. And that ends up getting multiplied by 7. And then over here we have this 24 divided by 4, which is 6. And that's added to 18. Some people did this addition first, but you have to do this 18 times 7, which is 126. And you're adding 6 to that, which ends up being 132, and that's the answer. Okay, I'm going to end the video here because it's already gone on quite a long time. I didn't go over the bonus questions. If anybody has any questions about the bonus problems, I'd be happy to go over that with you at a different time. All right, thanks for watching.